All right, so now we're going to continue through with Le Chateliers principle, and we are going to talk about how temperature can cause shifts in equilibrium as well. And so we're going to look at the same system as before, but we're going to add a little detail here. Maybe you can see it. I've circled it in bright red ink. But we still have the same reactants. We have the same molecules for products. But I've also added heat over here as a product because that is the case. This is an exothermic process. So how did I know that? Well, I looked it up. And so for an exothermic process, heat is exiting the system. It is exiting our reaction. It is a product. For an endothermic process, it would be a reactant. So I just looked up delta H. Delta H was negative, and I was like, oh, that's exothermic. Heat's a product. So this wasn't some sort of, Harry Potter's, wizarding world of witchcraft and wizardry or whatever. I just looked it up on a table. I didn't just make it up. I didn't manifest the situation. And it certainly wasn't anything I memorized. Now, being able to take this information and do that, that's key. Being able to understand where to get this information might be helpful as well. But more important is being able to interpret it. And so chapter 5 strikes again, just doesn't go away. It's the Freddy Krueger of this book. It just keeps coming back. Make 17 movies out of chapter 5 or something. Somehow with all the same characters playing exothermic reactions, because I don't think they ever recast Freddy Krueger. So I don't know. Just a random thought. You all have the internet at your disposal, so you can fact check me there and find out, oh no, I'm wrong. In the 15th, it was like some guy that didn't even look like him or something. Anyway. So we rewrite our equation. So we have added heat to it. You might see where I'm going here. All right, there's a new relationship that we're looking at. Well, if I increase temperature, it means I'm adding heat. If heat is a product, that means I'm adding a product. I'm going to shift left. Now, if I remove heat, if I lower temperature, I'm removing heat. And that is going to cause a loss of a product. And our system is going to shift right to compensate. So it's just like before, adding a product or losing a product, but now we have to be able to put heat into that kind of idea. We have to be able to introduce heat as a product or a reactant, and to do that, we got to know delta H of our reaction. So you got to be able to put those pieces together. And so again, for the system we're looking at, because it's exothermic, because heat is a product, we have these shifts. If it's an endothermic process, everything reverses, so it's very relative. But the idea that underpins it is the exact same. It's just, are we adding a reactant? Are we removing a reactant? Are we adding a product? Are we removing a product? We just have to be able to get heat into that idea somewhere. And that's what we have to do. So this one isn't too bad. Once you get the idea of, shift left, shift right. So, we're shifting towards reactants when we shift left. We're shifting towards products when we shift right. So the last one we're going to talk about here for Le Chateliers principle will be catalysts, and then we'll be on to the nitty-gritty math stuff.